Alright, an introduction to functions. Our goal today is to represent mathematical relationships using graphs. There are two types of graphs that we can sometimes talk about during our function chapter. We have qualitative graphs and quantitative graphs. A quantitative graph is easy. The key word in there is quantity, and on the x and y axis we will have intervals with numbers. A qualitative graph is different. Qualitative graphs are graphs used to represent situations that may not have numerical values, or graphs in which numerical values are not included. This is an example of one. This graph represents the relationship between time and percent of photos being downloaded. As we look on the axes, they are labeled, but they do not have numeric values. On the x-axis, we have time in seconds. On the y-axis, we have the percent of photos being downloaded. This graph can tell us some things, but it's a little more vague. It doesn't have an exact numeric value to it. At this point right here, no time has started yet, and no photos have been downloaded. From here to here, as we see, the line is straight. It's going up from left to right, which means it's increasing. So the percent of downloads are they're increasing. They're increasing at a constant rate because it's a straight line. And because it's pretty steep right here, the percent of downloads are growing rapidly. At this point right here, the downloads have ceased. From here to here on this line, on this qualitative graph, time is continually happening, but the amount of downloads are stopped. Okay? For some reason, we are not downloading. Maybe we downloaded everything in the one folder we wanted, and we're looking for a new folder. Maybe our Wi-Fi just cut out. We're having technical issues. But for some reason, the percent of photos have stopped downloading. From this point to this point now, again, the line is straight, which shows us that it is a steady growth, a constant rate that the photos are being downloaded again. Again, it's a very steep line, so that it's increasing pretty quickly over this short period of time. From here to here is a very short period of time, but a lot of photos have been downloaded. The percent of photos downloaded has increased a lot. From here to here again, we're experiencing no more photos being downloaded. And then from here to here, right, again, it's a straight line, so it's a constant rate that the photos are being downloaded again. And again, it's pretty steep, not as steep as this middle piece, but a lot of photos are being downloaded pretty quickly. In example 1, this graph displays the water level in a bathtub. Describe the change in the water level over time. So, our axes are labeled. Our two variables are time and water level. We're comparing water level over time. Here's our starting point. At our starting point, the water level is 0, the time is 0. Right? We know that. From here to here, the water level is changing. It's increasing at a constant rate, okay? And eventually it's going to get to a point where there's no change. From here to here, there's no change in the water level. This is where the water has reached the level that you want for your bath. You're stopping the water, then you're probably taking your bath from this time point from here to here. At this point right here, though, the water level is starting to get lower. It's decreasing again at a constant rate. What's happening is you're draining the tub until this point right here. At this point, the tub is no longer filled with water. It's completely empty, and the water level is back down to 0. These are both examples of qualitative graphs. Again, there are no numbers on the axes, and we're comparing two variables. Using graphs to relate two quantities. Graphs can be used to visually represent the relationship between two variable quantities as they both change. The graph shows the volume of air in a balloon as you blow it up until it pops. So we have air in a balloon. The variables are volume and time, and we're comparing the amount of volume in this balloon as time moves on. Now I wrote 0, 0 at the origin, because we're technically living in quadrant 1 in real life situations, right? If time is one of your variables, it's typically going to be on the x-axis. These zeros really wouldn't be here. I'm just helping that for visual purposes as we're learning this graph. And what's happening in this? Well, we're blowing up a balloon. So from our starting point to here, the amount of volume in the balloon has increased at a constant rate. This is you blowing air to the balloon. From here to here, you're most likely taking a breath. Notice the volume did not change, right? The air in the balloon did not get smaller, right? It did not increase either. Now again, it's growing at a constant rate. You're blowing more air to the balloon until you get to this area again. From here to here, you're taking in a breath again as you're getting ready to blow the balloon up. You blew the balloon up. From here to here, you're taking a breath. You're blowing the balloon up. But at this point right here, notice the volume instantly drops to 0. This would mean that the balloon has popped. There's no more volume in the balloon, and it instantly drops to 0. This is analyzing a graph. What are the variables in each graph? Describe how the variables are related at various points on the graph. Right now, you could pause this video and try to do these problems on your own. Determine the variables and think about what you think is happening in each graph. Welcome back. Let's see how you did. For problem A, we're talking about the board length of a piece of wood. Our variables are time and length. We have a set length of the wood. This does not mean that the piece of wood is from here to here. It just means that we have some length of wood. Time has gone by. Maybe we're measuring. And if you notice, the length of the wood drastically has changed from here to here. We probably cut it. We probably measured again. Maybe did another cut. Measured again. Did another cut. And at this point we have our board being the proper length that we need. Again, this does not mean that a board is actually this length. It just means that we are cutting it and it's getting smaller and smaller and smaller. For part B, the variables are cost and minutes of calls. And they're referencing here our June cell phone cost. As you can see, there was some set cost for our telephone bill. And it stayed this way for a long time, until this point. At this point, our cost of our phone calls is going up for each minute at a constant rate. A lot of cell phone plans now are unlimited, but not all of them are. The way the phone company works is they will give you so many minutes a month, and this is exactly how phone companies started. Let's use Verizon for an example. They would give you so many minutes a month, and let's just say 100 for a nice friendly number, and after 100 minutes of you talking on the phone for a month, they would then charge you so much money per minute extra. So if you talked for 110 minutes, they'd charge you for those 100 minutes and then so much money more for those extra 10 minutes. It'd be like, 25 cents a minute after that. Okay, so as you can see, it'll quickly go up at a constant rate for each minute after your allotted amount of minutes.